Quote from the book on design for sourcing. By fostering closer cooperation between R&D and procurement, the design for sourcing method generalizes specifications to such an extent that they no longer suit just one particular supplier. One of the world's most admired CPOs told me that design for sourcing is the core business of a buyer, and I couldn't agree more. Yesterday's procurement was a function that negotiated an acceptable price for a specification issued by engineering. Today's procurement has the mandate to drive the specifications in a direction that meets the needs of the end customer and at the same time is successful in the supplier market. In this video, we will look at a couple of examples from auto and tech, and we will buy a MacBook Pro for illustration. Let's get started. Making computer chips is a little bit like baking cookies. Some of them will come out of the oven perfect, and you will offer them to special guests. Some may not look so nice and may be a bit too well baked on one side, and you will eat those in the immediate family. In late 2020, Apple launched the M1 chip, the first step in replacing Intel CPUs for Mac. Or to be more precise, they are replacing both Intel CPUs and AMD GPUs by the M series chips. The M1 that first came to market in the chassis of the otherwise unchanged MacBook Air and Mac Mini were already pretty impressive. For my video editing tasks, a Mac Mini replaced an iMac Pro and I couldn't be happier with its performance. The M1 chip comes with an 8-core CPU and an 8-core GPU, a pretty solid upgrade from the 6-core CPU and 4-core GPU of the iPhone 12's A14 chips from which it is derived. But for Apple, the M1 was just the first step. Last year, they introduced a new range of chips to power the MacBook Pro line of laptops. For those, they went a lot bigger. In its top configuration, the chip boasts a 10-core CPU with a 32-core GPU. And as you can see here, compared to the original M1 chip, the M1 Max is huge. Now, the bigger a chip gets, the more likely it is that due to production issues, you will have bad areas on the chip. With these big and expensive chips, throwing away chips with a bad area becomes super painful. So what semiconductor companies have been doing for a long time is what is called binning, which means that they simply turn off the bad cores and sort the chips into different bins. Now, if you look at Apple's website, you can see a prime example for binning. The M1 Max with the 10-core CPU and the 30-core GPU is the chip from the best bin. These are chips without any bad areas. Next up, you have chips with some bad areas on the GPU, with 8 cores of the GPU turned off, giving us a 24-core GPU. Above that, you have the M1 Pro. The M1 Pro basically is an M1 Max with half of the GPU cores chopped off. There's speculation on what Apple does with the chopped off halves. Some believe that they will show up in the Mac Pro later this year. Anyway, the most we can expect from an M1 Pro is 10 CPU cores and 16 GPU cores. But again, there may be bad areas on an M1 Pro, and Apple offers it in an entry-level configuration with an 8-core CPU with 2 cores switched off and a 14-core GPU with also 2 cores switched off. And this is the smart way to do it. Binning allows Apple to address a wide range of customer segments. Apple's website shows us 4 price increments of up to $700 while ensuring a high output or yield rate at their supplier TSMC. And just to be clear, when I said bad area, I by no means suggested that the chips are bad. Each of them is perfectly capable and you get what you pay for. I'm certain there was no dispute between Apple's product marketing, engineering and procurement teams on what to do here. But in an alternate universe, we may see an engineering team insisting only to use chips with perfect cores. And that would drive down the yield at TSMC like crazy and make the cost of MacBooks prohibitively high. Unfortunately, what is crystal clear at Apple is not so straightforward in other companies. I'm still seeing lots of examples where product marketing people and engineers are pursuing local optimums without seeing the bigger picture. A lot of this is done with good intentions and caused by time pressure and other valid constraints. But sometimes it is also caused by a supplier gaining too much influence over engineering, resulting in key decision makers truly believing that going with a specific supplier's design is the best option. And this is where we need a confident and enlightened procurement to push back. There always is more than one option, and the earlier procurement comes into the concept stage and shows the engineers what is out there in the supplier market, the higher the chance for success. So there you have it, B7, Design for Sourcing, a purchasing chessboard method that probably makes the difference between the long-term success or failure of your company. Okay, I'm curious. Do you want to share your success stories with Design for Sourcing in the comments down below? And should you have a question, I will get back to you within 24 hours. Thank you for watching, and I see you in the next one. Bye.